Today we will talk about the topic bonding. There are three main types of bond: ionic, metallic and covalent. In an ionic bond, the electrons are shared between a metal and a non-metal. An example of this is potassium chloride. Ionic compounds tend to have very high melting or boiling points due to very strong intermolecular forces. Ionic compounds do not conduct electricity unless they are molten or in solution. This is because once the bonds are broken when molten or in solution, ions can freely move and carry a charge. In a covalent bond, the electrons are shared between two non-metal ions. An example of this would be H2O, where hydrogen shares one electron to oxygen along with another hydrogen. There are two types of covalent compounds: simple covalent and giant covalent. In a simple covalent compound, there tends to be low melting points and they do not conduct electricity. In a giant covalent compound, there is much stronger intermolecular forces, hence a much higher melting point. In a metallic bond, the electrons are shared between two metals. Metallic bonds tend to have very high melting and boiling points. Metallic bonds can also conduct electricity thanks to delocalized electrons that are free to move and carry a charge. Since we are talking about the structure of compounds, we might as well talk about electrolysis. Ionic compounds only conduct when molten or in solution, as the ions can then move around and carry a charge. Thus, during electrolysis, ionic compounds are usually placed within a solution, with an anode and a cathode on either side. Anodes are negative and attract cations, which are positive, whereas cathodes are positive and attract negative anions. At the cathode, hydrogen ions will be produced, unless the positive ion within the ionic compound is less reactive. In this case, the positive ion will be produced instead. At the anode, oxygen will be produced unless the solution contains halides, for example chlorine, bromine or iodine. In this case, the halide will be produced instead.